Okay, so in this video, we want to really start looking at how we're going to analyze these forces and look at diagrams and stuff and how we're going to communicate these differences. But in reality, when we're looking at laws 1 and 2, law 1 is we're looking at something that is balanced. Law 2, we're looking at something that's unbalanced. So remember, so if it's balanced, we have an acceleration equal to 0. If it's unbalanced, we have an acceleration not equal to 0. So here our total force equal to 0, and here our total force is not equal to 0. So there's some net force acting on it. So if we look at these two pictures on a tug of war, if we look at the first picture here, we want to ask ourselves, what is the total force of the system? Well, we have 300 newtons going to the left and 300 newtons going to the right. So we can say, so we got 300 going to the left, 300 to the right, they add up to 0. But I want to kind of write it out. So it's easy for you to see it in the head, but I want to get you guys used to writing this out and looking at it. So the force is MAX, which is equal to forces to the right minus forces to the left. We're assuming it's not moving. Well, we can tell it's going to be not moving because if I have 300 newtons to the right minus 300 newtons to the left, that adds up to 0. So that means my acceleration is 0, and that means I am balanced. So they're just going to sit there and it's just going to be pulling and pulling and pulling. So now let's look at the second picture. I'll circle that in blue. So we have 300 newtons going to the left and 100 newtons going to the right. So some of our forces in the x, MAX equals force to the right minus force to the left. So we already know what the answer is, but let's write it out so everyone sees it. So 300 newtons minus 100 newtons. Whoops, sorry, because I was going in the wrong direction. Erase. Sorry about that. You have 100 newtons going to the right minus 300 newtons to the left. So that's a negative 200 newtons. So that means this is going to the left. Remember the graph pictures that we were doing? So our mass times our acceleration is a net force of 300 newtons to the left. So we were unbalanced. And if we knew the masses, then we could find the accelerations and so forth. But we know that this whole system is going to be moving with some acceleration to the left. And here, they're not moving. And here, they're going to be moving. Okay? So this is kind of a great introduction to are you balanced or unbalanced. Another way of looking at it, so if we have a box, so let's get some masses in here of 10 kilograms. And I have a 100 Newton force applied to the right. We're going to ignore friction for now. Just kind of say it's floating in the air. So my total force is equal to 100 newtons. My mass is equal to 10 kilograms. And I would like to know, is it balanced or unbalanced? Well, I'm going to find my acceleration. Well, some of my forces in the x direction. And if you want to just jump to MA, that is fine. This is kind of a simple problem here where you can do some of the forces. X direction equals mass times A. Remember, this is force to the right minus force to the left. You don't have any forces to the left. So this is force to the right is 100 newtons. So we have a mass of 10 kilograms times A is equal to 100 newtons. Let me show you the algebra. So some of you are not best friends with algebra, so let's look at this. 10 kilograms here divided by 10 kilograms here. So those cancel out. So my acceleration is 100 over 10 is 10. 10 meters per second squared. So I am unbalanced. Okay. So that's another way. So this is also how we're going to calculate our accelerations. If I ask you if you had a 10 kilogram block and we have 50 newtons here and 10 newtons here, so here's a question I could ask you: what force is needed to balance the block? In other words, to balance, to cause the block to not move. Okay? So let's look at it conceptually, because a lot of these you can really answer without doing the equations. And I'm not going to see your work anyways on the exam, so I'm perfectly fine. And I want to show it to you conceptually, and I want to show it to you mathematically. So hopefully everyone through one of those formats will really understand what's going on. So I have 15 newtons going to the right and 10 newtons going to the left. So we need, I can already hear you shouting, we need 40 newtons going to the left. So I want it to be balanced, so some of our forces in the x direction, MAX, which is force to the right minus force to the left. So if you're not seeing what we just did conceptually, let's go through and look at it. We want it balanced, so that means my acceleration is 0. So 0 is equal forces to the right, which is 50 newtons, minus we had 10 newtons here, plus something. Okay, we don't know what that something is. So 0 is equal to 40 newtons plus the something. So I have to take the something to the other side and becomes a negative something equals 40 newtons. Take that negative, multiply everything by a negative. So the something is a negative 40 newtons. And that negative means it's on the left or it's going toward the left. Okay? So hopefully in these videos you can kind of get an idea of balance and unbalanced. And then different types of questions we're going to look at is how you can find the acceleration, how you can find the total force on the system, or how you can find an individual force on the system. So in the next videos, we'll work on looking at weight and friction and some examples dealing with those specific forces.